Hello everyone, in this video we want to see how we can make unroll version from the patterns that we have generated using geodesic pattern, for example, and how to make it ready for fabrication for the laser cut and add the connection parts and also the text tags to find which strip belongs to which part in the 3D model. To start, we draw one surface in the Rhino screen, and I'm going to make points on to extract the two vertices at the corners and make a 3D out of it. So I don't want to start with a flat surface but a curved one. So now I'm going to bring this surface into my Grasshopper screen, and then I can also internalize it so that I can delete the surface in the Rhino screen. Okay, in the start I will also use the custom preview so that have one specific color for my surface and make it transparent so that I can also see the grid behind it. Okay, to start with the pattern, I define two directions. I define this direction as the U direction and this direction as the V direction. And I will generate them using geodesic component. How to start? I will type explode and extract this curve, the boundary curve of the surface. And then I will use list item to extract the edges. So this is the first edge and this is the second edge. I will bring them into curve containers. So these two curves, I will use them to generate the U patterns or the U direction of the curves, and I will generate some points on them and then connect them together using the geodesic component. So to generate these points, I will use divide curve and use the same set of count. So let's say I will consider number 5 and connect it to both of these count or these numbers, and I can also change it, so there's no problem. Just it's important that the same number will be because I want them to be connected one by one. And now I can use the geodesic component and bringing this surface as the input for the surface. By double clicking, I can use this container so that it's easier to place where these curves are shown on my screen. And then I define these points as the start points and these points as the end points. What happened is that the direction of these points are not the same in these two sides. So to show that, I can also use a point list and if I increase the size to something like 2 or even more, you can see that this part it's from 0 to 5 in this direction, and in this one it's from this direction. So that's making the problem. To solve it, we can either reverse this list from here, or we can flip this curve from here, and then we don't need this reverse anymore. So it depends on which one you prefer, but the result is the same. So now that we have these geodesic curves, I will make one group out of this part and write the name of this group is the V curves. It's just something for me so that it's easier to find afterward. Okay, I want to have the same for the other direction. So I will just make a copy from this part, bring it here, and it was even better if I made one container for these two. and then only one curve here, so that's more looking like tidy. And here I will change it, so I want to use these two curves instead, so number 1 and number 3, and everything works. Just changing also this name to yeah, this one is V, the other one should be U. So we have these two direction of U and V. Now that we have these curves, we can also make a width from it that we also showed in the previous video. But here we want to focus on how we want to make flat elements out of it. So the aim is to make some kind of strips with a specific width that we can define, and then to see how we can have these connection points. For example, having this kind of connections that is based on what we have in the 3D model. So this is what we aim to extract. To start, I want to make the flat version from this U directions, and how to make it, I will just define one point here on the screen and define this set of points, this set of curves or flat strips on the ground. So I will use this point component, bring this point from the Rhino screen, and I'm going to similar to these curves, I want to also have these curves here. So I'm going to use one array, linear array, and bring them behind in this row. So in the Y direction, I want to make this array. So I will type Y in the negative direction, so that it's similar to what we have here. And also we can say how much is the difference or distance between these points. Let's say 5 or 4. And how many points do we use is based on how many curves we have, which is these curves. So for that I'm going to use a list length and extract this length and bring it to the linear array. So we have 6 curves and we have 6 points as well. And then these points will be the starting points for the line STL. That I will use this as the starting point, and the direction for these lines will be the X direction. And what will be the length will be the same as the length of these curves. So I'm going to type length. So this is different from this list length. This showed how many items we have, and this one is showing what is the length of each of these curves. If I just connect one panel to this length, you can see that the length of these curves is between 39 to 52, almost 52. Okay, so I'm connecting this one here, and now you can see that we have the flat version of these curves. To make it more understandable or more like a strip, we also need to have this width that we can define for it. And to do that, I'm going to use one move element. I want to make offset from each of these center lines and make in both sides of it. So I'm going to use a move component and define the Y direction as the direction for my move. And the width of the strips, maybe we consider it's 1 centimeter, so I'm connecting 0.5 into each direction of it. So 0.5 in this direction, and make 1 minus x for the expression, meaning that also 0.5 in the other direction. And how to make the strips or the surface of these strips, I'm going to use loft. But does it work like this? Let's see. If we just connect it, it's let's say overlapping or making a loft from all these curves together, and this is not what we want. So let's disconnect this, And what we want is to make each two as a pair and then compare or connect, make a loft between each two lines of these strips, so that each one is generating one surface. And to do that, we are using a weave component, combining or merging these curves to these curves. Does it work now? Still not. Why? Because it's considering all the curves together, and again, this is not what we want. We said we want each two to be one group. So to do that, we are making one partition list and defining that the set will be 2, the size of the groups will be 2, and then here it works. So we have these 6 strips. Now I'm going to also make one group out of here, bring it somewhere here, and type flat view strips. So what we need to do next is to also consider these connections in between, because this is the most important part. Otherwise the length is not so difficult to do, and how to bring these points in between. For this, we need to consider what is the cross sections, or what is the crossing points between these two set of curves. And for that, I'm using a curve X curve, which is making the intersection between two sets of curves. We can also find it inside the intersection tab in the physical. The first one is the curve. So I'm connecting this set of curves here and this set to the B. And let's see if it works. Let's hide all these parts except for the curves. And does it work like we want? No. What's the problem? It's making the first connection between U0 and V0, then U1 and V1, U2, V2, and vice versa. So this is not what we want, because we want for each of the curves in the U directions to check all the connections to the other V strips. So not just with the first branch, but with all of them. And to solve this issue, we need to consider this A as a graph. So meaning that it wants to be considered with all the elements with the V or in the B component, in the B input. So now that we have this set of points and everything is fixed, we can see that we have 36 points. That is because we have 4 here. Okay, we have the same number here. But we could even change it. Let's say we have 4 in here, and then we have 5 in this direction. And yeah, so 30 points in overall we have. And how we can use these points, because first we are using with these U directions, we need to make groups out of these points based on this amount. So considering 1, 2, 3, 4, 5, 6 in one let's say group, then the second 6 in the second group, and continuing the same process. And why we have 6? Because here in the V direction we have 5 as the division point, so we have 6 points in the other direction. So how we can solve it? I'm going to use partition list from this set of points, and I'm going to use 6 because we need 6 points. 1, 2, 3, 4, 5, 6. And now if I'm using explode tree to just see if they are really categorized in a way that I want, I can check it here. Does it look like that? No. What's the problem? The problem is that each of these points are considered as separate elements and they are not connected, or they are not considered together. So each of them are partitionized also in a different way. So to solve this, I'm going to flatten here. Now you can see that each 6 are considered as I want. Okay, now that this works, let's come back to this number. How to make it parametric so that if we change these numbers, it still works. Because now if, for example, I make it like 6, does it still work? We can see that it doesn't. So that we said that this number should be, and it's important to be from this v direction. So instead of this number, I need to make one plus and make addition from this number to 1, which means the count of these points in the other direction. So now if I use this one, now I don't need to manually change this slider each time, and if this number of curves are changed, I will get the right response anyway. So this is really important. And now that I have this set of points, I can also get this partition list and use it also for the t-values to find where are the location of these points and then transfer it to the flat elements. So I'm making a copy from it, this time connecting to the TA, which means the location of these points on the A or on this what we define the U curves. So now that I have this set of locations, I want to transfer it to these flat elements. And I have these lines, so I can use them and define this location on them. How to do it? I can use the evaluate curve component, defining this curve, and then what is the t-value from this list. Does it work like this if I connect? No, and it even gives me an error. What's the error? It says that the parameter or these t-values are outside the curve domain. So let's check here. We can type curve domain. What is the domain of these initial curves that we have here? I'm using a panel to show you. So you see it's from 0 to the length of these curves. And what is the domain here for these line STLs? It's 0 to 1. It's how this line STL works. So this is not working, and we cannot use these t-values for this without any changes. And how to change it? We need to reparameterize these values from their source domain, which is their curves, to the domain of 0 to 1, which is the domain used for this line STL. So I'm going to type reparameterize, remap numbers, and I'm using these values from their source, which is this domain, to the source of 0 to 1, which is the default value in the target. Let's see how it works. So it changed these values from 0 to 1 now. So let's see if I connect it here, does it work correctly? It doesn't. What's the problem? We have different set of structure of the data. So here we have 25, which is in 5 different groups. But here we don't have any group, and all the 5 lines are in one, there is no groups. So I'm going to make a graph here, and then it probably works, but it doesn't look correct. You see here. So what's the problem? Maybe I also need to make here a graph. Yes, and that was the problem, because each of these curves and each of these locations was specific to each of the curves, and then we also needed to make group or graft here so that it works correctly. And if you want to check if it really works now or not, we can have a check system, and that's by making an evaluate curve from these curves that we have from this line STLs, and also making one for these initial curves or these geodesic curves. I'm going to use one reparameterize for both of them, so that the domain of both of these curves is now between 0 to 1, and instead of these t values I can use a number slider between 0 to 1 and connect it to both of them. Let's also make a sphere for this point so that we can see where it's located, and yeah, maybe we can also increase the radius. And even we can change the color to make it more understandable. Yeah, like what it is now. So you see that it's in the location of 0 now. We can make it, yeah, to pass it from each of these points to see if they really have the same location in this 3D form and in this flat, and it really works. Okay, so we can make a group out of it also, and I will place it somewhere here and type check system. So it's just for us to check if it really works and everything is correct or not. Okay, now that we have these points and everything is fixed, we need to define these points here, define circles in here, because we need to use them as the connections. So I'm going to type circle, and then I can define what is the radius of this circle. Something like 0.2 seems okay. So even we can increase the size. But from this set of circles, the first and last one doesn't work, because in the laser cut it's not what we can use it anyway. So I'm going to delete these two, and that's by making a call index, deleting the first input, which is 0, and also the last one, which is just copying this one, connecting to the initial call index, and make reverse. So this way we can have only the ones in the middle that are usable. So this part is also, I will bring it here, shift it to upward, and then connect it also to this group, add to group. Maybe we can also make a blob outline, so it's easier and not combining with other elements that we have here. Okay, now that everything is fixed and we have these locations also on the flat elements, we need to add the text tags. And how we do it, let's make it more understandable here. Okay, so we want these curves that we have to have one tag on the 3D model here as the name of the strip. Then we need to also have some names in between to define what is the number of this connection. For example, I would decide to make it like U0, U1, U2, U3 and U4, and then for each of these connections I will consider A, B and C. So let's start. I'm using a text tag, but because I want to also think about the laser cut and make it easier, I will recommend to use this text for laser cut, which is from the OpenNest component. You can download it from the Foot4Rhino. And I'm considering the initial point from this set of points. So I'm going to type list item, and I'm going to say this starting point is the location for the writing the name of the strip. What will be the name of the strip? I will use one series, and yeah, how many do we have, how many curves is based on this list length, so I'm using this as the count for this series. And if I connect it here, what happens? So you see all the texts are on top of each other, which is not what we want. So we need to also make a graph in the text so that we have only number 0 for the first curve, then number 1, and we can also change the size for these. And let's say 2. Yeah, even larger. So now the text is correct, but we said that we can also add one U. To do that, I'm going to use concatenate that combines the text, and we can say here U, and connect then this series to the B. So if we connect the panel to it, we can see that it works like U0, U1, 2, 3, and 4. So I'm going to use this instead. Now that I have this text tag for the strips, I can also make the same for the flat elements. But before going that, I'm also going to make the tags for the connections in between. And how to make it? I'm going to make one copy from this text and concatenate. And then what I need to do is to define these locations. So from these locations that we have these points, what I want is only these 3 in between. I don't want the location for the first one and the last one, because we also deleted it here. So from this list, I'm going to type list item, or let's say call index, to define which ones we want to delete, similar to what we did here. So I'm going to say that from this list of points, I want the first one to be deleted and also the last one. Reversing it. And then these are the locations, but I need to also make a reverse, because the orientation or order of the points, we don't want to change it. We did this reverse here only to extract the last point of it. Now that I have these points, I can define it as the input for the text. But what else we need to do? We need to also define the name for it, because now it's the same name as the strip name, but we want to add it. For example, we said A, B, and C, name the connections. And here I can add one minus, just to make it like, see it here, U0 with a name, and then we have this ABC. So I will make a panel out of it and write A, B, and C, making multi-line data so that it's considering each as a separate branch and connecting it here. So does it work like what we wanted? Again, not. Why? Because we want each branch to be considered separately. So U0 wants to have A, B, and C instead in one list. So I'm going to make this graph here removed, and then making the graph here. So now that we have U0, ABC, U1, ABC, and until U4. So now everything is fixed. I want to make one group in here. Okay, why is it so big? Just these parts maybe, and write it text tag on 3D form. I will add one color for it, just to be easier to find it later. And then I want to have the same tags also on the flat elements, so I can use this part, copy it, and bring it here. Maybe I can copy all the text, select all the definition, and then bring it somewhere here. Okay, so the name of the strips, I want to add them here at the start of the strip, and that's by using these locations that we had. Oh, what is it doing? Oh, okay, we don't need the list item anymore because we have them just only as this starting point. What is the next problem? Okay, we don't need this graph anymore because it's working correctly, and this list was not, these locations was not a graph, so we didn't need to also graph the text. So this is correct here. And then for the locations or the connections, locations of the connections, where are the locations? Okay, we did it for the circles, so we also need to do the same process of col index for these points. I'm going to make a copy here, bring it here, and then yeah, we have these points here, and also make the reverse here. So this list will be the location, and yeah, everything works well. We have these locations and the text is added. Okay, so that this part is working. Now we can go for the V directions and copy the same process. So I'm going to copy all this part. Before that, maybe we also connect this part to this container so that then it's easier to copy. And yeah, let's bring it here. Maybe now we can just yeah, hide this text so that it's easier, and also hide all these parts. Okay, this time we need to consider this V direction as the input here. So I'm connecting this part to here, connecting it to the A, and the B is now this other curve here. So just changing the position of this A and B. And what else we need to change? So this addition, we used it first for the V, now we need to use it for the U. I connect it to this, and yeah, it should work. So let's see. So we have this set of, we can again use this explode tree here to see if this partition list is working correctly. Yes. And so do we see the location for this correct? Yes. And just we need to change it to the V also here. And this text also looks correct. Okay, just one thing, how is the let's say direction of our curves? Because here we are saying this starting point and these are the ending points. So let's change this order if we want to have them starting from this side and then coming here. Okay, now the starting point is correct and from top, because now I want to also make the flat versions starting from top and coming here at the ending point, similar to what we see in here. Okay, so yeah, everything seems okay here. Now let's go for the making the flat pieces. Instead of using this point here, I would say somewhere here, a starting point, and then I need one array in the x direction, and then the line scale will be in the y direction. So I need to make some changes here. Instead of this y, I'm going to use x, and I'm adding this to this group. And how many do I need? I need the number that we have here, which is 5. 1, 2, 3, 4, 5 elements that we have. Maybe we increase this distance or keep it like it is. It's your decision. And then the line STLs, we need them to be in the direction of y. But because to have it similar to here, I want them to be in the negative direction. So starting from top and coming to the bottom. Okay, so I need to still move it, or let's move this part, the U directions. Okay. Now that we have this part, we also need to change this vector for the moving. So instead of y, we need to have it in the x direction. And then everything should work, making these strips. And also the location for the circles. Let's see if it works correctly. It looks like it's correct, but we can also check using our system check that we set. You see, starting from here, coming to this point, here, here, and the ending point. Yes, everything is working correctly. So let's also check the text tags. For here, we have this text tags. We only need to also change this to V, and also change it here to V, and it's also working correctly here. Just changing this size would make more sense. A, B, and C. Yes, everything is correct. So yeah, this was the teaching for making the flat elements out of this geodesic. And because we have the setup all parametrically written, we can now change if we want something to be changed. For example, we can make the count to 6, and we can have the right location for the points. Only we need to add these numbers ABC, because it's repeating if the number are more than what we set. So we only need to change this part here, that we are seeing it's repeating the C, So if we have more, so we have yeah, this location, we have 5, so we need to also have 5 alphabets here. And then yeah, everything else is working correctly. So that's it for today. I hope you enjoyed the video and making nice structures, and you can easily laser cut and build your models. Thank you.